welcome back to the channel. So today in this video lecture we're going to be solving this problem, minimum time to visit a cell in a grid. So in this problem we're given a m cross n matrix grid consisting of non-negative integers where each element represents the minimum time required to be able to visit that cell, represented by the pair row column, which means you can visit the cell only when the time you visit it is greater than or equal to the grid row column. That means you can visit a cell represented by a pair row column only if the time that you visit is greater than or equal to the time or the element which is present in that cell. Okay. So now you are standing on the top left cell of the matrix and you want to reach the bottom right cell of the matrix. Okay, and from any cell you can move to any of the four adjacent cells, and the starting time for you is 0 second. We have to return the minimum time required in which you can visit the bottom right cell of the matrix. If you cannot visit the bottom right cell, then you can return -1. Okay, so now let's just better understand the problem statement using an example. So let's take this example. We have a matrix of dimensions 3 cross 4. In this matrix, what do we have is, this is the starting cell that is 0 0 and this is the ending cell that is 2 3. We want to reach this cell 2 3 starting from the cell 0 0. Okay, and the time initially when we are standing at the cell 0 0 is 0 seconds. Fine. So now we can move from the cell 0 0 to the cell just right to it and to the cell just below it. Okay, we have one of these two options. We can see that here we can move to both of these cells. Okay, now the problem statement says that we can only move to an adjacent cell if the time t at that moment is greater than or equal to the element which is present in that cell. So when I move to any of the adjacent cell, t will increase by 1 because it takes 1 second to move to the adjacent cell, as it is given like here. Each move you make takes 1 second, and therefore when we are moving to any of the adjacent cells, we are incrementing this t by 1. That means when we are visiting this cell 0 1, t is 1, and hence we can visit this cell safely. So initially we visit 0 0 at time 1 at time 0. Now I visit cell 0 1 at time 1. Now from this cell I can visit cell number 0 2 only, because this cell becomes invalid, that is cell number 1 1, because the time will become 2 now, and 2 is okay. So we can visit this cell 0 2. We cannot visit this cell 0 2 from this cell 0 1 because t becomes 2 after one more move, and this 3 is greater than 2, therefore this cell cannot be visited. So we visit this cell 1 1. Now we are here and the t becomes 2, so 1 1 is visited. Now from this cell 1 1 I can visit this cell 1 2 or this cell 2 1, and this time becomes 3. Okay, so the cell is 1 2. So which one? We can visit any of these cells. So let's visit this cell 2 2. Okay, so the cell 2 2 is visited at time t is equals to 3. From this cell, like it's 1 1, it's 1 2 not 2, the cell 1 2 is visited from the cell 1 1. Okay, so we move to cell 1 2. Now from the cell 1 2 I can move to cell 1 3 or to cell 2 2. The time t becomes 4. T becomes 4. Can I visit cell 1 3? No. Can I visit cell 2 2? No, because the elements here are greater than the time that we have. The time is 4 seconds and the elements are 5 and 8. So what is the solution here? In this kind of scenario, what we do is we can move back and forth between the cell 1 2 and its previous cell, that is 1 1. I will move back and forth between these cells until my t exceeds this 5. Okay, that's the scenario. Now since the t becomes 4, the difference between this t and the time in the cell is 5 minus 4, that is 1 unit of time, or 1 second, or 1 minute. So what does that mean? That means I have to move. So now I am on cell 1 2 and the time is 3 seconds. I cannot move to cell 1 3 because the time in the cell 1 3 given is 5 while t is 3 seconds. That means before I move to cell 1 3, t must exceed this 5. So that means I have to move back and forth here. So from cell 1 2, I move back to cell 1 1, giving me a time t of 4. Then from cell 1 1, I move back to cell 1 2, giving me a time of 5 units. So from cell 1 2, I move back to cell 1 1. Then from cell 1 1, I move again to cell 1 2, and the t becomes 5. Now from cell 1 2, I move to cell 1 3. So now I move to cell 1 3, giving me a time of 6 units or 6 seconds. Finally, it exceeds this time given in the cell 1 3, and now from cell 1 3, I move to the cell 2 3, giving me a time of 7 units. Okay, now I am standing on the cell 2 3, and the answer is 7. Fine. So in this fashion, I'm going to solve this problem. So let's see the implementation. Let's see how we can solve this problem. The solution is simple. All we have to do is just run the Dijkstra algorithm. Okay, because we have solved a lot of problems on Dijkstra algorithm in my Dijkstra algorithm playlist series. So this problem is very similar problem. We have a source cell which is cell 0 0. We have a destination cell. We have some constraints that we can only move to an adjacent cell if the time that has been elapsed is greater than or equal to the time which is given in the grid cell. Okay. So simply use a priority queue. So I use a priority queue. In the priority queue, push the initial cell with the time. The time is 0 and the cell is also 0 0. Use a distance array of the same dimensions. Okay. So use a distance array of the same dimensions. So the dimensions are like this. And initially I am standing on the cell 0 0, and here we have 0. The distance is 0. Now from cell 0 0, so I pop this cell out of the priority queue. So from cell 0 0, I move to its adjacent cells, and t increases from 0 to 1. Okay, it increases from 0 to 1. So I move to cell 0 1. We can see that t is greater than equal to this one. So I'm going to push this cell into the priority queue. So push cell 0 1 into the priority queue with the time which is 1. Okay, and the distance here becomes or the time here becomes 1. Now pop this cell out of the priority queue in the next iteration. So from cell 0 1, I can move to cell 0 2. No. Can I move to cell 1 1? Yes. So push this cell 1 1 along with the new time which will be 2, because t becomes 2 and the distance here becomes 2. Now again in the next iteration, pop this cell out of the priority queue, and here from this cell, and also try to move to this cell which is 0 2. So since I moved to cell 0 2, how can I just visit this cell 0 2? It's obvious, if I want to visit cell 0 2, then the t that I have, which is 2 seconds when I move to cell 0 2, it has to be increased up to at least 3. So for that, I will simply move from cell 01 back to cell 000, elapsing 1 second more. So t becomes 3, and then from cell 00 I move back to cell 01, giving me a t of 4 seconds. Now from cell 01 I can move to cell 02, giving me a time of 5 seconds. So to reach cell 02 I require 5 units of time, and hence I will push this cell 02 into the priority queue along with its distance, that is 5. So the trick is simple. If I can move to an adjacent cell with the time which we have at that point, then simply visit it and push the corresponding cell into the priority queue along with its time to arrive at that cell. Otherwise, if the time in the adjacent cell, or the element or the integer in the adjacent cell is greater than t, then you have to move back and forth in the previous cells to exceed the time or the integer given in the adjacent cell. Okay. Finally, you are able to visit the adjacent cell which you couldn't visit previously, like I did here for the cell 02. In this fashion, you will have the best optimal distance or the time to reach this cell 2, 3. Like here in this case, it would be 7. Fine. So that's the strategy. Let's just implement the solution. Let's see the pseudocode for it. So you can see that here we have our minimum time function which takes in this grid, calculates the dimensions of the grid, initialize a distance array with a very large number. Now declare a priority queue PQ and push this cell 00 along with its distance into the priority queue. Now initialize this distance for the cell 00 with 0. Now iterate over this priority queue till it is not empty. Pop the top vector from this priority queue. Separate its component, that is time, x and y. XY represents the coordinates of the current cell, while this time represents the time that we have taken to reach this cell x and y. Iterate over its adjacent cells and check we have any valid adjacent cell. So if we have any valid adjacent cell, then for that valid adjacent cell, update the new time. That would be time plus 1. This time is the time that we had to visit the cell from which I am coming, that is cell xy. So this is not xy, this is nx ny, that is new cell. So if the new cell is valid, then visit it, increment the current time by 1. Now check if the current time is less than the integer that I have in the neighboring cell. If it is the case, then update this current time. So the current time is simply updated like grid nx ny, which is basically the time that we have there in the neighboring cell, plus the difference between so this value is either 1 or 0. So this value depends upon the number of back and forth movements that I have done. That is, if the difference, like here, if the difference between the neighboring cell new time that I have is less than the integer which is given in the neighboring cell. If it is the case, then I update the neighboring cell with this new time and I push the neighboring cell along with its time into the priority queue. Fine. So in this fashion, I will have my array, I will have my distance array prepared, and at the end I will return that array from this function. So this distance dot back gives me the last element in the matrix. Fine. So that's all for this problem. Let's just jump to the code implementation. So let's implement it. Let's calculate the dimensions of this matrix. It would be int n. That would give me grid dot size. Let's calculate m. That would give me grid 0 dot size. Okay, so let's declare a distance array. So vector of vector distance of size n and then we'll initialize it 1a9 plus 7. Now initialize the distance for the cell 0 0 with 0. Declare a priority queue. It's a min heap. Let's push the cell 0 0 along with its distance. Iterate till the priority queue is not empty. Pop the top element from the priority queue. Segregate the components, that would be top 0, the cell, the x coordinate of the cell, top 1, and the y coordinate of the cell, that would be top 2. Now iterate over the neighboring cell. For that I will be using a direction vector 0 -1 0 1 0. So iterate over this direction vector and move to the adjacent cells. So int I 0 I less than 4. So let's say nx would be x plus dri, ny, that is new coordinate for the y cell, would be y plus dri plus 1. Now check here if this is a valid cell. If min nx ny is greater than equals to 0 and nx is less than n and ny is less than m. If it is the case, then push this cell into the priority queue. So push this, the time will be here. So if it is the case, then the time that we have here, the new time, let's declare another variable, new time, that would be time plus 1, and then check if this new time that we have is less than the time that is given in the adjacent cell of the grid, nx and ny. If it is the case, then this new time will if it is the case, then that means we have to move back and forth until I exceed the integer given in the adjacent cell of the grid, and that would be new time plus it would be grid of nx and y plus the distance that okay, so that would be, so grid nx and y minus the new time that we have modulo 2. Fine. Now I check if this new time is less than the distance that we already have for this new cell. If it is the case, then it is worth updating this distance, because we are getting a better distance since I want to find the minimum distance to reach any cell of the given matrix. So that would be updated by this new time, and we'll push this pair into the priority queue. So push this new time along with 0 along with this cell new x and new y into the priority queue. Fine, so that's all. Also pop this node from the priority queue, and also I forgot to mention a condition, that is if the adjacent cell for the top left cell 0 0 contains number greater than 1, so if min of grid, the cell grid 0 1 and the cell grid 1 0. If it is greater than 1, then that means we'll have to return -1 right from here, because we won't be able to visit that cell. Like here in this case, let's take this matrix. I would have 4 here. Let's say I would have 4 here. So in this matrix, if I would have 4 here, like 4 in this case, like in this matrix, if I would have 4 here, then obviously I can neither move to cell 1 0 nor I can move to cell 0 1, because the maximum time which I can have is 1 unit, because it was 0 in the cell 0 0, it would become 1 while I move to any of these adjacent cells, and there is no cell to move back and forth. Therefore, in this kind of scenario, I just return -1. That is, it is not possible to visit the bottom right cell of the given matrix. So from this cell, return this dot back. That is the last cell of the matrix. Distance array, that is. Let's just submit this code. Okay, it got accepted. So that's all for this video. If you like the video, then hit the like button and make sure to subscribe to the channel.